Hello students, in the last class we have completed electrode potential concept. Now we'll move to the next concept, that is representation of a galvanic cell. So before going to the representation of galvanic cell, let us recall the concept, that is electrode potential. As we know the definition of electrode potential, what is the definition? Electrode potential is nothing but the tendency of an electrode to undergo either oxidation or reduction. That is electrode reaction. So based on that, it is classified into two types, that is oxidation potential, that is tendency to undergo oxidation in this case, whereas and second one is reduction potential, where the reduction potential is nothing but tendency of the electrode to undergo reduction reaction. As you know that what is meant by oxidation reaction? Oxidation reaction is nothing but any metal which undergo oxidation. Oxidation is nothing but loss of electrons. So this is the reaction. This reaction, that is oxidation half cell reaction. Whereas reduction potential, reduction means gain of electron which gives rise to metal, and this takes place at cathode. Oxidation takes place at anode, whereas reduction takes place at cathode. Reduction takes place at cathode, anode and cathode reactions. What is meant by cell potential? By combining these two with the help of a salt bridge and connecting wires, we are going to get the galvanic cell. So the potential difference between these two electrodes is known as cell potential, and this can be calculated by the formula E cell, that is cell potential of a cell is equals to E right minus E left. Right side में कौन सा रहता है? Cathode cell, this is present in the right side, whereas anode half cell is placed on the left side. E right minus E left, where this E represents electrode potential and the subscript R represents right side, L represents left side. Right side reduction reaction takes place, at the left side oxidation reaction takes place, and these are reduction values. These are reduction potential values, not the oxidation potentials. And we also studied some of the factors affecting the EMF of the cells. If not, just you can note factors affecting the EMF of the cell. That means the cell potential of a cell. Cell potential or even electrode potential. Simple electrode potential also depends on concentration of electrolytic solution. What is the concentration? Whether it is less concentrated or more concentration, 1 molar, 2 molar, 10 molar, 0.1, etc. Some X molar. Nature, second one, nature, both nature of electrode and as well as electrolyte. Electrode and electrolyte. Electrode and electrolyte, both. And temperature. These are the factors which affect the value of electrode potential. Now sir, let's move to some of the facts about the electrode potential. What is that facts? Simple one. If an electrode which having higher oxidation potential values, which means which having higher tendency to undergo oxidation. Similarly, if an electrode, that means metal, which having higher reduction potential values, oxidation potential values, reduction potential values. If it having higher oxidation potential values, then the electrode having greater tendency to undergo oxidation. If its reduction potential value is more, then it have high tendency to undergo reduction. And as we know that by IUPAC convention, electrode potential is restricted to reduction potential values. Whenever we are talking about the electrode potential, which means that it is a reduction potential only, not the oxidation potential. In the present literature, that is in this topic, wherever we are using the term electrode potential, which means that is a reduction potential only, until and unless if the mention SOP, that is oxidation potential, or if it is given an oxidation reaction, in that case we can use it as oxidation potential. But if it is not mentioned, in that case we need to select a reduction potential. This is according to conventions. The electrode potential is restricted to reduction potentials only. It is a reduction potential. I will explain by taking some example on this. So, how to represent an electrode potential? Representation of electrode potential. How to represent an electrode potential? So, let's have a look on this. Electrode potential. Representation of electrode potential. Suppose a metal M, कौन सा भी metal ले सकता है. You can choose any metal M, that is an electrode which is present in solid state. If it have a tendency to undergo oxidation, oxidation is nothing but loss of electron. N number of electrons are lost, so plus N, this metal M undergoing oxidation. Or suppose if the metal ions having high tendency to undergo reduction, reduction is nothing but gain of electrons, so ions, metal ions gains N number of electrons to form metal in the solid state deposit. That means this is a reduction reaction, this one is reduction reaction, whereas this one is oxidation reaction. Oxidation reaction. Now this can be represented in two ways. The first one is oxidation potential is represented by metal bar its ion. So electrode potential E, electrode potential E, this electrode potential is represented by putting a subscript metal M bar M plus, that is ion. So this one is an oxidation potential. This represents this subscript, this symbol which represents standard oxidation potential. Standard oxidation potentials. Look at the subscript M bar and slash M plus ion. That means M is going to undergo oxidation. So therefore it is an oxidation potential. Now in this case the electrode potential is represented by E. It is a symbol of electrode potential with the subscript. This subscript indicates whether it is oxidation or a reduction. Now in this case M plus is present in the LHS side, that is left hand side. M plus ion, that is this is electrolytic solution, ions are there. This is converted to M, that means M plus ion gains n number of electrons and to give product. So this one is called as standard reduction potential, SRP, standard reduction potential, not PRS. It is just SRP, standard reduction potential. Okay, standard reduction potential. Now suppose, let us consider one example, zinc and copper in the Daniell cell. As we know that example in this present topic, Daniell cell examples already we have considered. Just recall that reactions. In the Daniell cell, the metal zinc which is placed at the left hand side, that is lone, that concept we have remembered, lone. Left side O4, O represents left side oxidation, that electrode is known as anode and which is negatively charged, negative charge terminal. Okay, lone. Now zinc is placed at the left hand side. This undergo oxidation to give Zn2 plus ion plus loss of 2 electron. So this can be represented by electrode potential of Zn bar Zn2 plus Zn slash Zn2 plus, its value is 0.76 volt. With respect to standard electrode or reference electrode it is measured. We are going to discuss about this determination of electrode potential in the next class. So these are the values it is given, standard values. Now similarly at the right hand side, copper electrode is dipped in copper sulfate solution. So these are copper Cu2 plus Zn solid which undergo oxidation in the left hand side in Daniell cell. Similarly in the right hand side, that is reduction half cell, Cu plus 2 ions, copper sulfate ions which gains 2 electrons to give the product Cu copper, that is E cell. Electrode potential is represented by first reaction mein Cu plus 2 is present in the left hand side and Cu is present in the right hand side. So Cu plus 2 bar Cu. So this reaction represents reduction, and this represents oxidation. This values, the standard values, this represents, this is SOP, standard oxidation potential, SOP, whereas its value is 0.34 volt. This values represents standard reduction potential, SRP, and this one is SOP. Now I am making a small change. If this, according to IUPAC conventions, electrode potential is nothing but reduction potential, but this one is oxidation reaction. So I am writing this as Zn2 plus slash Zn. What is the change? Look at the change. Initially it is Zn slash Zn2 plus. Now in this case Zn2 plus slash Zn, that means this one undergoing reduction. So what is the values? This value is same but sign is opposite. So SOP and SRP for a given electrode or for a given metal, both the values are same with opposite signs. So oxidation potential SOP values is 0.76, it is in plus, whereas Zn plus 2 slash Zn, that means reduction potential of zinc electrode is minus 0.76 volt. Similarly here also you can write the oxidation potential of copper Cu bar Cu plus 2, copper value oxidation potential is minus 0.34 volt. Now as you know that higher the value of oxidation potential or reduction potential, that having particular tendency to undergo electrode reaction, greater the value of oxidation potential undergo oxidation. Now look at this, reduction potential value is minus 0.76 volt, whereas the oxidation potential is plus 0.76 volt. Among these two, this value is higher. So that means zinc having a tendency to undergo oxidation. Don't compare these two values. So with respect to two different electrode, we can predict oxidation and reductions. I will explain in the further application part. So here just I am giving some important facts about the electrode potential. So just note these points. Zinc undergoing oxidation. So its oxidation potential is represented by this and reduction potential can be represented, but these two values are opposite. In general I can write standard oxidation potential. Suppose if SOP values for a metal, any metal, its value is suppose X, then its SRP values can be written as minus X. Is it right? SOP of any electrode is X. Suppose oxidation potential का values X है, then उसका reduction potential values कितना रहता है? Minus X, because just an opposite, negative sign. Just you remember this one. And along with, you can remember one more point. Higher the SRP values which undergo reduction reaction. higher the SRP which undergo reduction, R values reduction, R, higher the SRP which having high tendency to undergo reduction. And as you know that the substance which undergoing reduction is called as oxidizing agent, right? Oxidizing agent. That means for an oxidizing agent or a reducing agent, oxidizing agent is one which undergo reduction, For a substance to undergo reduction, its SRP must be high. That means which having high SRP values. If its value is low SRP, then which is said to be a reducing agent and which undergo oxidation. Among two given values, for example, you can note this one. For an example, if A, B, C and D are the different electrodes, its value is given, different electrodes whose SRP values I am giving here. SRP values of these 4 electrodes. Suppose, assume you can choose any values. In general, just I am giving the explanation on this. If suppose electrode potential values of these A, B, C, D 4 electrodes is, let's say its value is 1 volt, its value is 2 volt, its value is 3 and its value is 4. Or even you can take one value is minus also. 1, -2, even 0.3, 0.46, etc. 1 volt, unit is volt. Okay, now among these 4 electrodes, can you predict which one is oxidizing agent among these 4? The good oxidizing agent and good reducing agent among these. So in order to predict this, it is very important concept. In order to predict the oxidizing and reducing agent, you need to remember this. Higher the SRP undergo reduction. The substance which undergoing reduction, which is a oxidizing agent. So in order to predict the oxidizing agent which having higher SRP, so among these 4 values, 1 volt is the largest value. So therefore higher SRP means which undergo reduction, which is a oxidizing agent. This is the best oxidizing agent. Now the best reducing agent is B, because it's -2, the least value. So it is, this one is higher SRP, it is oxidizing agent, and this one is a reducing agent. The best oxidizing agent and best reducing agent. Even they can ask, arrange these in the increasing or decreasing order of their oxidizing potential or oxidation potential or reduction potential. And your values is given: oxidizing tendencies, reducing tendencies, ability to undergo oxidation, ability to undergo reduction. They can ask, arrange these 4 electrodes in the increasing or decreasing order, so that we can predict based upon this concept. These are just basic facts, and again these concepts we are going to study in the next concepts, that is in electrochemical series and its applications. Also the same concept we are going to study with the different examples or numerical problems. So this is about some facts of electrode potential, and these facts, that is electrode potentials के बारे में हमको जरूरी है in order to understand the next concept, or in order to calculate the cell potential of a cell, we need to know about these concepts. So these are just facts. Now let's move to the next concept, a representation of a cell. The next concept is cell representation. Cell representation of a cell. So simple concept is cell representation करने का. As you know that DNA cell, okay, DNA cell consists of, DNA cell का construction and working we have studied. DNA cell which consists of 2 beakers. In one case, zinc rod is dipped in zinc sulfate solution. The zinc rod dipped in zinc sulfate solution, and copper rod dipped in copper sulfate solution. These two are externally connected by means of an voltmeter and a plug key, and internally connected by salt bridge. This is the construction and working of Daniell cells we have studied. Zinc rod dipped in zinc sulfate, copper rod dipped in copper sulfate, right? And this one is salt bridge. Now it is a cell. This cell can be represented by, how we are going to represent, what are the components which are present in a cell, how we are going to represent. As you know that, look at this, the cell which consists of two half cells, the half cell which is present at the left side is known as oxidation half cell, whereas in the right hand side, that is we can call reduction half cell, oxidation half and reduction half cell. Which reaction is taking place in the oxidation half? In the oxidation half cell, oxidation half cell, oxidation reaction. Here zinc electrode is present, so it undergoing oxidation to give Zn2 plus electron. Whereas in the reduction case, copper plus 2 ion gain 2 electrons and which undergo reductions, right? These two reactions. And this oxidation half is represented as anode. At the anode, that is left side, anode terms, and this is cathode, anode and cathode. In this side, metal starting is metal which is converted into its ion. So metal and its ions are separated by a slash or bar, single. Similarly, whereas in this case, ion is present at the left hand side which is converted into metal, right? Metal. So oxidation half and reduction half. These two, oxidation and reductions, are separated by a salt bridge. So this salt bridge is represented by a double slash. This is the cell. This is a cell representation. देखिए बहुत सिंपल है. Cell representation. The cell representation, how we are going to represent a cell? The simple. The cell can be represented by separating the oxidation half cell and reduction half cell by a salt bridge which is represented by two, that is double slash. In oxidation half, first metal is separated by its ion, whereas in the second case ion is separated by metal. And remember, in this case the concentration of ion should be mentioned along with physical state also we need to mention. Let us consider the example. The same example we will consider Daniell cell representation. First, okay, here only we can consider salt bridge, left hand side oxidation. So which is the metal? Metal is zinc metal. It is in solid state, right? So this is converted to its ion, that is which is undergo oxidation Zn2 plus, which is present in aqueous. What is the concentration of these ion? We need to mention its concentration C1 is its concentration, and this is separated by salt bridge, that is double slash. Next, right hand side reduction taking place. Cu plus 2 ion which is present in aqueous medium, its concentration, let's say C2, which undergoing reduction to give copper, that is salt. This is a perfect cell representation of Daniell cell. Zn plus 2 in bracket, you need to represent its concentration separated by salt bridge. Copper plus 2 ion bar copper, this copper plus 2 ion का concentration भी उसके bracket में represent करना चाहिए along with physical state solid, aqueous, solid. This is a cell representation. How we are going to represent a cell? Now I will give one more example how you are going to represent a cell representation, or I will give one simple reaction. By that you can write the cell reactions. cell reactions you can write. So now the first one, magnesium and nickel or silver or nickel electrodes we'll consider. Copper, iron, zinc, copper, silver, copper, aluminium, nickel, etc. you can consider. Now let us consider one simple example. अब aluminium का consider किया तो aluminium, nickel, copper, zinc, iron, silver, aluminium, nickel, copper, zinc, iron, silver, etc. Any electrode you can choose. Any electrodes you can choose. Based upon its potential values, you can write the cell representation, right? Cell representation. Because we don't know which one is anode and which one is cathode among these two. So, by using this concept, that is oxidation potential, it's based upon the SRP values. We can predict which one undergoing oxidation and which one undergoing reduction. So based on that we can predict. Now suppose if the aluminum potential, now I will give two values just for example. Aluminum values Al plus 3 bar Al plus 3 bar Al, whether it is reduction potential or oxidation potential. Check it, reduction potential, oxidation potential, its value is minus 1.66. Similarly Ni plus 2 bar Ni, nickel plus 2 bar nickel, its value is minus 0.25 volt. देखिए, these are the two values I have given in this case. Yes, this one is oxidation potential or reduction potential? Of course reduction potential, because starting plus 3 ions are converted into 0. That means Al plus 3 ions to solid. Reduction or reduction potential, both the values are reduction potential. Now predict among these two values which one is least values and which one is highest values. Highest value 0.25 is the largest values among these two because it is in minus, compared to minus 1.66 minus 0.25, this value is larger value. So higher the values, which higher the reduction potential values which having tendency to undergo reduction. That means nickel ion must and should undergo reduction. Now you can write the reaction. This one undergoing reduction, we have predicted this is the largest value, so this must undergo reduction. Now in a cell, if one electrode undergoing reduction, then other must and should undergo oxidation, so this undergoing oxidation. Now you have both these, you will come to know which one undergoing oxidation and which one undergoing reduction. Oxidation is present at the left hand side, reduction is present at the right hand side. These two are separated by salt bridge. Left hand side reaction, salt bridge, right hand side reaction. Okay, now in this cell, left hand side कौन सा reaction होना चाहिए? Oxidation. Now if it undergoing oxidation, can you write the reaction? Let us write this reaction. Before writing the cell representation, first I am writing this one. This have a tendency to undergo oxidation, but this is given as a reduction. Oxidation का reaction लिखिए. Al gives rise to Al plus 3 bar, Al plus 3 plus 3 electrons is lost. ये oxidation हो गया. This one is oxidation. Now write the reduction reaction. This one is reduction. Nickel plus 2 ion, इसको 2 electron चाहिए. Therefore it is 2 electron gives rise to nickel, that is solid. This one is reduction. Now can you represent this? Okay. E subscript में क्या लिखना चाहिए? In E subscript or simply cell representation चाहिए तो first metal bar its ion Al plus 3. Similarly here nickel plus 2 ion bar nickel. Okay. Now you can represent the cell. First oxidation half cell. ये oxidation का है. This one is oxidation part. Therefore aluminium, which is solid, which undergo oxidation, Al plus 3 aqueous. Bracket में क्या लिखना चाहिए? Concentration. But in this case, just simply I have not given the concentration terms, so directly you can write, or you can mention C1 in bracket also, no problem. Now right hand side reduction. Reduction कौन सा है? Nickel. So here nickel Ni plus 2 aqueous in bracket its concentration bar nickel solid. So this is the cell representation of a cell which is made by two electrodes, one is aluminum and nickel. These values, look at these values: electrode potential of aluminum, electrode potential of nickel, electrode potential of copper, electrode potential of zinc. These values, the values of these electrodes of various elements used in this literature are not the absolute values. These values are determined relative to the common electrode, that is a reference electrode, standard electrodes. So what is the standard electrodes? What are the reference electrode? How it is constructed and how it works? How these values are determined? Zinc electrode potential is 0.76, for copper 0.34. How these values are determined? So that concepts we'll study in the next session. So in the next session we are going to move towards standard hydrogen electrode or normal hydrogen electrodes. इसका construction and working के बारे में स्टडी करेंगे, and after this calculation of cell potential of a cell, how we are going to calculate the cell potential. So this concepts we'll study in the next class. So in tomorrow's session, along with this I will provide some of the assignment problems you need to solve based on this concept. I have prepared some questions I will upload in the Google Classroom. So please solve those problems and submit the answers. We'll check it. Okay, thank you.